Hi, I am Paul Bell from the National Oceanography Centre in Liverpool. Our main office is down in Southampton, so we have two sites and I'm a part of this Swot project. We have our own offshoot of that, which is Swot UK, funded by the National Environment Research Council and the UK Space Agency, and that's to focus specifically on the calibration and validation phase, where the Swot satellite will be passing over the Bristol Channel and Severn Estuary. And one of the reasons this is particularly interesting from the entire project's perspective is it's pretty much the only large estuary with a high tidal range that's being passed over by the satellite during that one-day fast repeat cycle. The Severn Estuary itself and the Bristol Channel has one of the highest tidal ranges in the world. It's something like second or third in the world in terms of tidal range. So that means, in practical terms, the water rises and falls by up to 14 or 15 metres twice a day on spring tides, which is an awful lot of water moving around. Going with that, obviously, are some very large currents, and it's quite a heavily populated area. So some of the areas surrounding the Severn Estuary and Bristol Channel are quite low-lying and are at risk of coastal flooding. So from a perspective of why do we care about these kind of measurements, there are lots of tide gauges and infrastructure dotted around the Severn Estuary and Bristol Channel. They don't always match up perfectly with predictions and models. And the question is, why is that? I mean, they're not big differences, they're quite little differences, but in modelling terms and in terms of how we normally expect these calculations to run, they're a little bit bigger than we'd like, and maybe that's to do with changes in water density from the river inputs. It could be from weather effects, but one of the overarching assumptions in a lot of this work is that the tidal surface is quite a well-behaved, smooth entity, and that's probably not the case. The dynamics are such in the Severn Estuary that there's probably lots of lumps and bumps in it that will change over time depending on what the conditions are. And the Swot satellite, with its really high resolution, will actually show us this in 2 dimensions, and that's something we've never really been able to see before. So this will help us to understand what it is we're missing in the physics, and therefore where to go next, because it's the unknown unknown.
Which is what might ultimately help also understand what's going on with waves in this
The Swot project itself is really quite a short mission in satellite terms. It's only due to last just over 3 years. That may well be not enough time to look at what we're looking for. If what we discover turns out to be really important in physical terms, that's a really good argument to look at a follow-on mission and actually monitor at these resolutions continually. We've already found from conventional SAR satellites the value of long-term monitoring at what are conventional resolutions, but that's just with imagery. The Swot satellite's actually measuring the sea surface height, and at the moment with conventional altimeters and such like, the spot width they can look at is really quite large. It's several kilometres across. With Swot we can look at much smaller pixels and really work out what's going on. And in terms of the average sea surface height, this is the sort of thing that really matters. The local variations in sea surface height due to local dynamics and local changes really matters to things like flood defences, flood warnings, all that kind of thing. It's always nerve-wracking when a new satellite goes up. The risks are evident. We'll keep our fingers crossed. I know SpaceX has a very good reputation for getting things into space. It's exciting because we've just never seen this kind of data at this resolution. What are we going to find in there? We have suspicions that all these wonderful lumps and bumps in the sea surface are going to be there, but are the patterns going to be what we're expecting? What I actually hope is that we'll see something we weren't expecting, because that's where the fun bit is. And that's usually what happens. We go looking for one thing, we find something else, and that leads us down a different path, and that's the nature of research.